Work seems to be constant at Google, doesn't it? This time, Google's DeepMind, the state-of-the-art artificial intelligence research laboratory, has recently released the brand new Gemma 3 model. Built on the same effort and research that went into building the Gemini series, users of Gemma 3 will find that it is light and easy to deploy on a single accelerator. It doesn't matter if it's deployed on a GPU, TPU, or even some other form of hardware such as AMD GPUs. What users have realized is that this is one of the most capable models, if not the most capable model any user can run on any device. What's so special about Gemma 3? What's even better about Gemma 3 is that it's still one hell of a performer. Another reason many are excited for its release is that it comes with a combination of advanced text and visual reasoning capabilities. For starters, it comes with built-in support for 140 or more languages, and it can also handle a huge context window that's made up to 128,000 tokens. The developers among us know that this is huge for an open model, even though you could say that this is becoming the standard in the industry. Multimodal model. Another feature that makes Gemma 3 so special is that it represents the true concept of multimodality. That is because not only can you feed images, videos, or texts into it, the model can handle each format like it's nothing. Some say that this is due to the fact that it is using a vision encoder technique that is referred to as SIGLIP, an image embedding model that's designed to create numerical representations, embeddings of images, allowing computers to understand their content. It is so powerful because it comes with a frozen 400 million parameter vision backbone that essentially converts images into a series of 256 visual tokens. What comes next in the process is that these tokens are fed into the language model portion, and this allows Gemma 3 to respond to queries concerning pictures. Same goes for questions concerning the identification of objects and the reading of texts that are embedded in images. Pretty multimodal, right? Pan and scan. Another feature that makes Gemma 3 so special is the pan and scan feature that helps the model cut up images into smaller crops. This helps in preserving the details in the images. This has proved to be especially useful when it comes to dealing with non-square formats or images that have text in them. That way, the user would find that all the sharpness in the images have been preserved without stretching or squashing the image into a one-size-fits-all shape. Different sizes of Gemma 3. Speaking of not wanting to fix things into one-size-fits-all shapes, users will find that Gemma 3 has been released in 4 different sizes, those sizes being 1B, 4B, 12B, and 27B parameters. As you can imagine, the 27B is the largest of all the models, and it seems to be the best of the bunch. For example, looking at how it tests on the LM-SWES Chatbox Arena, you'd find that it has an ELO score of 1,338. This is amazing, because this makes it rank better than many older open models such as DeepSeek V3, O3 Mini, or the 405B version of Llama 3. As such, even though it is smaller than some of its competitors, it actually does very well when it comes to user preference. What also makes Gemma stand out is what its architecture looks like when you take a peek underneath its hood. To reduce that massive memory overhead that you may find when you push context windows towards the realm of 128,000 tokens, you'd find that Gemma 3 makes use of a number of local self-attention layers that are spread out among fewer global layers in a ratio of about 5:1. This works to reduce the memory footprint, especially as not all layers have to attend to the entire 128,000 tokens. This works to give the model an ultra-long context without having to make use of a huge system of dozens of GPUs to hold the memory. This helps to cut the memory overhead to about 16%, a massive reduction from the 60% if every layer had to be global. Quantized version. Another thing that users may find interesting about Gemma 3 is that it's being shipped with several official quantized versions. Quantization may be described as taking all the 16-bit floating point weights so that they could be compressed into int4 or float8 representations. That way, the models fit into smaller memory footprints. They are able to do this because they experience a small round of quantification, aware training, and knowledge distillation, which serves to improve the accuracy of the model, and this works even though it's making use of fewer bits. As such, users may find that quantification is a big deal when it comes to running these big models on smaller hardware. What users may also find is that Gemma 3 still makes use of the same sentence piece-based tokenizer as Gemini 2.0. This means that it still makes use of 262,000 vocabulary entries across 140 languages. This also means that they make use of knowledge distillation from bigger teacher models. That said, smaller teacher models can also work for short training runs. Users will also find that Gemma 3 supports function calling and structured outputs so that it can run function signatures without hacky prompts. Despite such safeguards, users, especially the developers among us, will find that they still handle safety responsibly when they deploy open models such as Gemma 3. They may find that when it comes to the hardware side, Gemma 3 has been optimized in a way that allows for NVIDIA GPUs, Google Cloud TPU, AMD GPUs via RCOM and CPU execution with something called Gemma.cpp. For those using the NVIDIA GPU systems, you may find that you like how they are able to maintain direct optimization from the Jetson Nano to the top-tier Blackwell chips. This feature is even detailed in the NVIDIA catalog, so you may be able to carry out rapid prototyping from there. At the same time, if your preference is running everything through Google Cloud, you may find that you could spin it up on Vertex AI, Cloud Run, or through the Google Gen AI API. There is also the option for those who just want to mess around with it on their local machines. Such people may do so by downloading the weights from Kaggle, Hugging Face, or Llama. Shield Gemma 2. Another interesting piece that came out at the same time as Gemma 3 is Shield Gemma 2. This is a specialized 4B parameter image safety checker that makes use of the Gemma 3 architecture to allow developers to scan images for 3 categories of content: dangerous stuff, sexual stuff, and violent stuff. As such, you can say that it is an innovative solution to keep your pipeline free of images, texts, or videos that may come under the 3 aforementioned categories, especially if you don't want it in your dataset or user feed. Academic research. Another interesting push is the academic program that is run around Gemma 3. Apparently, DeepMind is making an offer of $10,000 worth of Google Cloud credit to academic researchers who want to carry out serious research with these new models. If you're an eager academic, you must jump on this offer because it is only available for a few weeks. This may help them fuel the so-called Gemmaverse, a broader ecosystem where thousands of variations of Gemma have come to fruition in the last year or so. Think of examples such as AI Singapore's Sea Lion Thief 3 or Nexa AI's Omni Audio. Such open models have allowed people to build specialized derivatives such as language translation to advanced audio processing. Technical report. Looking at the technical report that was released recently, you'd find that it gives us a lot of information when it comes to how Gemma 3 was tested. These reports mentioned standard benchmarks such as MMLU, Live Code Bench, BirdSchool, and a variety of multilingual tasks. They also mentioned that the 27B instruction-tuned version of Gemma 3 is in the same performance league as the best open model. Indeed, one chart shows that it may even be better than the older Gemini 1.5 model in certain tasks. They were able to do this by relying on improved post-training or instruction tuning that makes use of a multi-step approach, mixing advanced knowledge distillation from a larger teacher model, as well as reinforcement learning methods that incorporate code execution feedback. They also tested intensively when it came to vision tasks such as DocVQA, InfoVQA, and TextVQA. This represents the massive improvements when images are properly handled at a higher resolution. Add the fact that these Gemma 3 models are trained with a risk-appropriate approach in mind, and you'd find that the more powerful the model, the more evaluated it is. Gemma 3 apparently got a specific check based on misuse for making harmful substances, and it was concluded that the risk was low. As they continue to refine their approach to such measures, you'd find that Gemma is bound to get better and better. With any luck, it may even be one of the best models out there when you get your hands on it.